So cool. Yeah, thank you everyone for coming. I don't even have employees who show up at 10 a.m. on Monday, so this really means a lot. This is my first time speaking at GDC and also being the first talk at GDC. Yeah, it's crazy. I hope everyone has a good GDC ahead of them. GDC. So yeah, my name's Thomas O'Connor. I'm here to help you guys navigate both the technical and the administrative work that goes into console game development. I'm going to give you just a quick rundown about me and my company before we dive into the actual the work here. So we're a team based in Seattle, and we love console game development. We started this company right after college to work on an original game for the Nintendo DSi because we were really excited about Nintendo's digital storefront, meaning that it made console games accessible to indie developers like us. Of course, college debt meant that we weren't going to be doing a lot of indie work without holding down day jobs at other companies. So our team, everyone on our team was working elsewhere at the same time: Fuel Cell, Fifth Cell, ArenaNet, Microsoft, Hi-Res. So we were doing console game development during the day and then indie games at night. I'm sure some of you know moonlighting isn't exactly a very productive way to do indie games. So we didn't actually finish a whole lot. One job that I had before going full-time indie was with the developer support group for Nintendo. My primary focus there was on supporting the HTML5 platform for the Wii U. It was called the Nintendo Web Frameworks. I also wrote and maintained documentation on the developer portal that outlined the development process start to finish, which is pretty much what this talk is, except for we're also covering Xbox and PS4. So about 7 years after the company started, we finally made the plunge to go full-time. And then we turned our focus, instead of making our own games, we're going to help other indie games get brought over to consoles. So this is a bunch of the games that we've been working on just this last year. Most of these have been for the Nintendo Switch, but we're also doing Xbox One, PS4, and the Nintendo 3DS. Most of our projects have been in Unity, but we're also doing Unreal, C++, and Monogame. So this is our roadmap. This is what the process looks like start to finish, or start to never finishing. It's reasonable for an already completed game to take about 3 months, possibly up to 6 months. This is where people get kind of depressed or they think that they could do it faster. You probably can do it faster, but you should plan for at least 3 months. If you're doing online multiplayer or any advanced networking features, then it's recommended to give yourself at least twice as much time. They can go faster if you're familiar with the process. So we'll go over the general process of getting everything set up. We'll dive into a few technical details about development itself. I do have a whole lot of Unity stuff in here, but porting Unity games isn't meant to be the main focus of this talk. If there are any important topics that you felt I left out, we'll have a Q&A session that you could please bring those up at the end. There's also a bunch of things I will not be talking about: low-level graphics programming, specific API calls on the system, basically anything that would be under NDA. Hopefully it can still give you a good bird's eye view of the process so you know what's ahead of you and you can avoid some costly issues down the road. Before we get started, also I'll go over some terminology. If you know all this stuff, I'm sorry. So the dev kit is a development hardware version of the console system that will let you run unlicensed code. It looks pretty much like a retail device, but it's set up so you connect it to your PC either through USB or over the LAN. Your host PC is your computer that just has all the development tools set up. Once your host PC and the dev kit are connected, you'll be able to deploy and debug software to it. A ROM is an archive file, like a zip file, that contains all of your game's executable and all of its resources. It's like an all-in-one bundle of your game. I will often use the terms mastering and authoring interchangeably. It's the process of creating a ROM from a build of your game using the development software provided. And certification is a big one. So this has different names on each system. Nintendo calls it lot check, Sony calls it FQA. This is just their process of checking your game against a list of requirements to make sure that your game meets the standards and that they've outlined and protects their system and users. So these are the sign-up pages. You can Google these too. You don't have to actually memorize URLs. Everyone these days, I believe, is now approving developers based on the titles that you're applying with. So I guess technically these are application pages, not sign-up pages. If your title's approved, then you're able to register your company, and you really should be a company for these guys, and get access to their development portal, and then share access to your team members. It's there you can download development tools, order development hardware, and find things like documentation, forums, and web tools for managing and submitting your game. And a heads up that Sony still requires a static IP address for developers to access their portals. Comcast is really expensive to do that, so you can get a VPN if that's easier or cheaper for your studio. So getting your development environment set up is a whole lot easier these days, so this wasn't exactly an easy slide to write about the problems you'd run into. For most of the systems, you'll need to install an SDK, which provides your code access to the system features. And there are also tools that will let your PCs connect with and interact with the development hardware. Once your development hardware is set up from your PC, you can do cool stuff, deploy your software, take screenshots, update the firmware, brick it, cry. It's actually not as easy to brick a dev kit these days, but it's definitely still wise to be careful and make sure that you're giving yourself enough time to pore through the documentation. There are some very fickle steps sometimes, but recovering from mistakes is just a lot easier these days. But pretty much every time we had a submission due, something would go wrong with the dev kits that would take up our entire day. The license would expire on them, the SDK version would expire, some reset or format operation would end up wiping all of the development accounts, and we wouldn't remember how to create development accounts. One thing that is still quite troublesome with dev hardware is the development accounts, especially the ones that are supposed to have special or limited online privileges. Microsoft has this with Games for Gold. Nintendo has this now with their Nintendo Switch service, or online service. My recommendation is that the documentation on this is not very good. So as you go through this process, write down your own documentation and keep it on hand the next time you need to make additional accounts. Okay, so the great news that pretty much everyone should already know is that most of the game engines used by indies are supported on most platforms. So a quick question, how many people here are using Unity for their game? That's a lot of people. How many people are using Unreal? That's a good amount of people. Nice. How many people are using C++ or something native? Sweet. And there's a handful of people. And then how many people are using something else? Monogame or HTML5? Good for you. There are options for you. It's just, they're not great. The important thing to remember is getting set up is that each of these companies that have middleware have their own turnaround time for verifying your status as an approved developer and then getting you access to their software. So even once you get access to Sony stuff, you're still going to need some time to get access to Unity or Monogame or anything like that. So before you actually start developing your game, there's a whole bunch of actual pre-publishing work that you should do. You're going to have to register your game. You've applied, your title was approved, but it's not actually in the system. Registering in the system will give you a title ID, or it's also known as a game code. This identifier makes the system aware of your title so that you can configure the backend services like achievements, leaderboards, and also do things like schedule a submission. There are some platforms like Sony or the Nintendo 3DS, you're going to have to register your title separately for different regions. North America and Europe are both managed by essentially different companies. All console games need to have a rating provided by the age rating agencies that operate in each region. You probably know the ESRB here in North America. In Europe, there's PEGI, and USK, there's also CERO for Japan. For digital games, some of these are free. Some of them still cost money, and they might even need video footage of your game or even an actual copy of your game running on the system. It's important to know that for scheduling. If you need a version of your game that you can send them, and that could take weeks before you can actually submit. Fortunately, most systems are now supporting IARC. IARC is an international coalition of the rating agencies. This means that you can apply just once and get ratings from a bunch of agencies all at once, and it's free. This is great because it makes regions like Australia and New Zealand accessible to indies. Typically, those have been pretty expensive ratings to get. And the last thing that you should do before you actually get started in development, or while you're getting started, is setting up the backend service config. So all of your online systems like achievements, trophies, rankings, if you're going to access any independent servers, you're going to have to configure the development servers before your game can actually use those features. All console platforms have web tools in their development portals that will let you set these up. It can take a little while for the companies to process your configuration, so please make sure you just give yourself a couple of days. So this is just a handy reminder for everybody to just know your contacts. There are developer support teams to help you with your technical issues. There are the publisher teams, which are there to help you find the right person to talk to. They help you plan your release, and they'll work with you on all of your marketing assets. And then there's the testing teams, and these are the ones who are the most familiar with the certification requirements and the testing procedures that they'll use to break your game and break your heart. A good example of why I like to bring this up. So when the testing team comes back and they're saying that they can't approve your game for release because your game doesn't properly handle the user signing out in the pause menu, complaining to the testing team about the business impact of your game missing its planned release date isn't going to help. They're not going to care. So cool, everything's set up. You got your dev kit and you're running sample code on the dev kit, and now you're ready to go with your own project. Every time you bring your game over to a new system, there's all kinds of low-level system work that you're going to need to deal with, unless you're using a game engine like Unity or Unreal, and it takes care of this for you. Adding low-level platform support for these systems is pretty straightforward, since all of the systems provide sample code that you can compile, run, and copy as needed. This is along with all the work you would expect that you need to do to make the game fit on the device, like making UI changes, controller support. So specifically about Xbox, along with making sure your game just works, there's a list of features that systems like Xbox supports that the certification will be testing against directly. Some of these features are required, like achievements and proper user account management. In fact, user account management is one of the more involved features to implement correctly because it has a direct impact on the flow of your game state. You can go from the welcome screen to the main menu into the game, and then suddenly you're supposed to go back to the welcome screen. Or you have to deal with the fact that loading and save data is asynchronous, so you can kick off the operation and it may take seconds before it actually completes, and it could even fail. Sony has pretty much the same list of features. They have a very different setup and implementation than Xbox One. There are cool features like the light bar and the touchpad, and those are totally optional. I don't know if anyone actually does it. This is my favorite slide to write, because Nintendo always makes it really fun to work on their systems, because they always have the most unique platform features. Typically, this is a turnoff for, I think, for most indies who want to do a quick port, because the work that you would do for Xbox and PlayStation doesn't really carry over. And historically, their development hardware hasn't been very easy to use. I think the Switch is a great machine, and it's absolutely my favorite system to work with right now. HD Rumble is one of those features that our team, we like to spend a lot of time with the games that we port, because it has such a huge impact on how polished a game feels. HD Rumble is like a more precise version of the usual haptic feedback that you find in modern controllers. It turns on and off much quicker, it has a much broader range of vibration frequencies, and it pairs really well with audio to reinforce the effect. Support for multiple controller styles is actually pretty easy to implement, and doing it will give players more choices on how they want to play with single Joy-Con, both Joy-Cons, or in handheld mode. With any of these systems, the more features that you integrate, the more your game will feel at home on the system, and potentially the more the platform holders are interested in leveraging your title and their own marketing agendas. So if you have time to make your game feel special in the system, I recommend doing it. This was my life for a while, and this is the life of a lot of people who are still working in technical support. The job of a technical support engineer is just problem solving for other developers. There's a couple of different ways to get in touch with technical support teams. It usually depends on the type of issue that you're having. Is it a question specific to the SDK that you're using, or is it about the hardware that you're using, or is it something specific to Unity or Unreal? It's important to remember that it will take a while for your questions to get an answer, and most of the time they're just going to answer you with more questions. To help yourself save time before you even contact support, try to imagine all the questions somebody unfamiliar with your project would ask and answer them preemptively. Break down the issue as small as possible. If you can reproduce it in a standalone app, that's great. The simpler the repro situation, the quicker support can help with finding a solution or a workaround. Also, when you write up your issue, please outline everything you've tried already and the outcomes. Okay, so this is the fun part. A lot of people in here are using Unity, so I have a lot of notes for you guys if you were planning to come to console. The development workflow with Unity on consoles is not what I would consider ideal. I had a friend call it something like programming through a long, narrow straw. What the situation is that Unity can't run and directly debug your game running on the device. Your C# code isn't even what's actually running. It's been transpiled over to C++ and then compiled again into the executable. So the C# project that you have from Unity can't connect or debug what's running on the device. The way that Unity makes builds means that you'll often be making a full rebuild of your game and deploying it to the device every time you want to test even a small change. We've had build times that are anywhere from 10 minutes to 45 minutes, sometimes an hour and a half, depending on how big the project is. So you have to plan your debugging a little bit more carefully. If you're trying to test new features that require quick iteration, for example, if you were going to try a variety of HD vibration feedback effects or your leaderboard implementation, it helps to create a small test project in Unity that you can make new builds of quicker, has fewer scenes, or just don't include all the scenes when you make a new build, just include what you need. It's very important to know about what cert coverage Unity provides out of the box and what features you'll be required to implement. A lot of people I know think that Unity supports a platform, it's a push of a button, and you're done. It's half true. So Unity will take care of things like rendering, file I/O, memory, threading, but that still leaves you a lot of work to do in order to hit cert coverage. You'll need to make sure yourself that your game properly supports everything else: account management, achievements, input, especially the Switch's various controller styles. There are plugins for Unity for each platform that does make it easier to add this functionality. These are native plugins binding the platform SDK functionality over to C# code, and you bring that into your project so that you can connect those SDK functions to your game code. An example of this is pressing A on the welcome screen will bring up the Xbox One account picker. Or connecting or disconnecting a controller on the Switch, you can bring up the controller applet, which lets players confirm their desired controller style. One thing that Unity does really well is encapsulate the metadata configuration for your title. Every platform needs you to configure your ROM with the data, your title ID, images like the dashboard icon or splash screen, your trophy or achievement data, your age ratings, and the submission number, which we'll go into later. Usually it's it's a unique process for each platform, but Unity centralizes it for all three of them. So yeah, version numbers. If you're planning to go, different version numbers, sorry. So Unity version numbers. If you're planning to go to consoles anywhere in the near future, then I recommend you do not update to the latest version of Unity, even if it is really shiny. Support for consoles isn't immediate with each Unity release. There can actually be quite a delay sometimes. But also, not all previous versions are supported. In fact, you might find that you're actually quite limited on which Unity versions that you can use on any given system. Unity releases are tied to SDK versions, and all SDKs always have an expiration date. So even if you kept your game in, say, Unity 5.6.3, you might actually be forced to update it just because that version can no longer make ROMs that are accepted for submission. Another thing you can never do enough of is testing. If you've dealt with Unity updates on PC, you know that there might be small bugs that you wouldn't notice until you're running the game. This issue is just made a little bit worse on on consoles. There can even be small issues between minor versions, like a P1 or versus P4, and they could be difficult to spot. The good news is that you can have multiple installations of Unity living next to each other. So the next time you install a new version of Unity, I recommend that you put the version number into the installation path folder. This is my life right now. I'm buying hard drives every month. You'll notice here that I'm keeping track of the Unity version numbers along with the SDK versions that they depend on, but that's just me being neurotic. A friend of mine does like to suggest changing the Unity shortcut icon from the default icon over to either the PS4 or the Xbox icon, depending on which system you're actually using that version for. And I should have mentioned that you will get a different version of Unity, even if it's the same version number for each platform. Okay, so some actual development tips, important things to know about that you'll run into with a Unity game on console. Asset bundles is a really tough one to talk about because it's a confusing topic, I think. I heard Unity has some big updates coming to this system, and hopefully they'll be changing it, making it a better system going forward. But right now it's a little awkward, and it's also pretty much required on some systems. So these aren't asset bundles that are being provided by a server online, which as I understand, that's how mobile games are currently using asset bundles. These bundles are actually placed into your streaming assets folder and are shipped with your game. If you put your scenes into an asset bundle, then you no longer need to include those scenes when you make a build. So this can greatly speed up your build times if you're only making changes to code. This does, however, have a huge impact on your workflow for anybody who's still actually making changes to scenes or prefabs or assets. It's best if you can build your system where you can toggle on and off using asset bundles so that you can use it at the end when you're iterating on builds. Another reason to do this is that Unity is non-deterministic when it comes to building assets for each platform. So every time you make a build, even if you made no changes, the layout of the binary files will be different than they were previously. This means if you were to make a patch from 2 builds that had no actual changes to them, the patch size could be quite large. We had a really good example of this when we ported Mr. Shifty to the Nintendo Switch last year. A build that was not using asset bundles would come out to about 4 gigabytes. When we made our first patch that was just code changes, the patch size came out to about 3 gigabytes. After working with the developers to update their game to use asset bundles, the final ROM size came down to about 800 megabytes, which the patch size was at about like 700 megabytes. It was a drastic savings. I want to love player prefs. I really do. The first thing I end up looking for when I evaluate a Unity title for porting is to see where they might be using player prefs and how easy it would be to rip them out. Player prefs are often used as a save game system. It's really easy to write save data out anytime it changes and just read it in whenever you want. It's a very convenient and lazy approach. Unfortunately, player prefs are not supported on every system, and even when it is, there are some concerns about its write frequency, which there are certification guidelines about. So when we do a port, we pretty much have to strip it out and replace it with a more robust system. So if you were to think about a game's save data, you can break it down into 2 parts, the serialization of the object state and then the actual read-write operations to disk. If you use a solution that has a clear separation between these 2 parts, it will make your porting a lot easier since you only actually have to port the file system read-write code. It's a pretty fugly graph I butchered to sort of show the separation. The serialization and deserialization process handles converting the object state into a memory buffer. Pretty often that's a string, maybe JSON, maybe XML. And then the block in red is the file I/O. So you take that string and you write it to disk or read it from disk. Having that separated means that you can implement a platform-specific file I/O, which is you're required to, and then you can more easily handle the case when the saved data is corrupt or writing failed. Okay, so debugging strategies. This is the part that's really tough. You can debug in the editor when you run on PC. That's often not very helpful, especially if you're testing something very specific on the hardware, like vibration or rendering or shaders. You can put a whole crapola of debug log statements all over your code. I guarantee that no matter how many you put in, you will miss putting in the one that you actually needed until your second or third build. Sometimes you can debug the IL2 CPP generated project. The IL2 CPP source is the C++ source that Unity generated as an intermediate step when building your project. Your build can be configured so that it gives you access to this project sometimes, but not all the time. And using that project can be useful when trying to track down an uncaught exception or another fatal error. It's useless to try and edit it. The code is written by a computer. But if your game does crash on the device, you can load this project in Visual Studio, attach it to the device remotely, and then view the call stack to help you find out what script might actually be to blame. And then go back and add a bunch of print statements. So I have more notes here than I actually wrote on the slide, so it's weird. But so your performance optimizations, there are a whole bunch of common CPU issues that we've seen with Unity on consoles. The quality settings just being too high, particle effects being too intense, audio decoding from too many voices playing at the same time, too many draw calls. Static batching does help a lot. Dynamic batching doesn't always help, so you try it on and try it without. Post-processing effects that are causing too many draw calls. In fact, on Mr. Shifty for Switch, we found a bug in the version of Unity that we were using where static batching wasn't actually being used when doing the depth pass needed for SSAO. By turning off SSAO, we actually saved about 15 frames a second. And then there are your classic Unity script performance issues. If not caching your components, not utilizing physics groups. Just follow all the best behaviors, best practices for performance scripting, and you'll be in better shape. We've rarely actually seen CPU issues with Unity on consoles, so that's pretty fortunate. So third-party plugins are a double-edged sword. They can indeed make your porting life a lot easier by giving you a more robust platform abstraction, especially for things like audio or input. Rewired, In Control, and Wise are some great examples of these. To complicate your issue with Unity versioning and SDK versions, keep in mind that your third-party plugins also have version dependencies. One issue that we ran into was with the dialogue system plugin for a game called Phantom Trigger. We had to update the plugin after updating the Unity version for the game, but we didn't realize that their update actually fixed bugs in their plugin, and that the game had actually unknowingly depended on those bugs being there. So otherwise, this is actually a pretty minor issue, but weird stuff like that constantly keeps coming up. If the plugin already supports the platform, then that means they are already testing their plugin on the platform, and they're likely able to help debug or fix the issues you might find. If the plugin has source code available, then even if they don't support the platform, you can build it, but their support might not be so great. Okay, so that was it for Unity and development. So now we're on to submission. Oh, this part's fun. So the timeline here depends basically on just how busy the platform holder is with testing other games in submission. Whether you fail or your timeline depends on how busy the platform holder is with testing other games, whether you fail, and then what issues you fail for. I'll warn you now that you may have many times where you'll be waiting around for days or weeks just to eventually find out that there's a serious issue with your game, and that can be pretty frustrating. And you will fail. It's guaranteed. If it's your first time, you will almost certainly fail. And it's not a bad thing, just prepare for it. So the process for submission is different for every platform, but basically the structure of it is the same. You're going to generate a final ROM. This should be a non-development build. All of your game debug systems should be turned off. All of your optimizations turned on, and everything else that you can squeeze in to make your ROM as small as possible. And then testing. I cannot stress enough about testing your final ROM. It is crazy how many times we've had weird stuff that only showed up in the final build that we were ready to upload that wasn't showing up in the development builds that we were testing beforehand. Or how many times while I was working support where we found games come in where they had fixed a bug that was in their second submission, and then only to have that bug come back in their third and fourth. Most often, you'll be uploading your ROM through browser-based tools, but out to each company, Sony or Microsoft or Nintendo. But outside of that, there's not a lot I can say outside NDA. Each platform holder has some very specific instructions on how to send them a submission. And this is another section where I highly recommend writing your own documentation about the steps you took as you go through it so you can reference it for your next submission. For the platforms where you had to register your title for different regions, you're also going to have to submit different packages for each region. So basically, every time you have a different title ID, that's a whole separate submission. So like Sony of America and Sony of Europe, you're sending them separate builds. Oh, and please keep a copy of your previous submissions somewhere. You're going to need those for regression testing and for generating patches. And if you're using asset bundles in a Unity project like we recommended, then you should keep a copy of those bundles as well. It'll help that if you also keep notes about every submission as well. Keep track of what SDK version that you use, what middleware versions you use, and then changes between the game in every submission. This is what actually got me to finally pay for a Dropbox account. So this is an example of what we did for LA Quest on 3DS. We went through a lot of submissions. The naming scheme here shows which region, separate title IDs for North America and Europe, the submission version number, and then the date. Okay, so this is a warning for everybody, but this is also the support engineer and me just really wanting to stress this on people. After you've been waiting days or weeks just to find out your game is approved or not, you get a final notification about its status. No matter how it goes, you get approval or failure, it's very important to remember these points. The failure reports are not conclusive. That means testing may have found something, found enough issues to warrant a failure, but it does not guarantee that they found everything. You could get an approval report, but that is also not conclusive. They may not have found any issues blocking your game from release, but that doesn't mean they found everything. In your next submission, they might find it. Cert testing is not QA. They're not going to test your game for actual gameplay bugs. They might let you know if they run into them. And if you can, just be kind to the testers when they send you a report of issues in your game. It is very frustrating to have them find something on your third submission that should have been there the whole time, but it is not their job to catch everything. Their job is to evaluate whether your game is doing enough to protect the system and its users. So I try to put together a list of all the common failures that we've ran into in the last couple of years. And there's a whole bunch of them. Like I said, you're going to fail a lot. So age ratings is one. Age ratings are part of the metadata that is actually configured into your ROM, and they must match the ratings that are configured in the paperwork in your title's registration. It's very easy to get this wrong because every platform has a different way of representing age ratings. ESR, if you got an M rating, that means the value should be 17 on Nintendo, but it could actually be the value is set to 9 on Sony. Paperwork issues are usually just mistakes when you are filling out the submission form or forgetting to include some other submission materials. Thankfully, paperwork issues are very easy to correct, and they often don't hold up your submission. This one's important. Every time you submit, you have to increment a submission number in your package. Or for submitting a patch, you have to update the application version number. Every system has a different file in which you do this, but everyone has the same process. You just add one. Title stability is one of the biggest issues we've also ran into. Since I'm not porting my own games, I don't think this is my fault. I think it's hard enough to do testing as an indie, and often cert testing will run into crashes that you didn't even know were in your game. Sometimes they can actually be very specific cases that you didn't even think to test. A good example is LA Quest on 3DS. There was an issue where the game would not shut down correctly if you used the home menu button while the Miiverse application was open. They shut down Miiverse, so I think I won. Okay, so terminology and branding is a really big one, and all the platform holders are very particular about the language used around its features. If you use an Xbox One controller image in your settings screen, then you better change that to a DualShock controller on PS4. There are a couple times where I've missed localization strings that reference things like joypad, porting a game from PC to console, or calling it rumble on Xbox One when it's actually officially called vibration. I think I already warned you about user account management and how tricky it can be. This is especially true on Xbox One, where the user has more flexibility about when they sign out and the game needing to respond appropriately. We have issues with Xbox One where if you constrain the title by going back to the main menu and you sign out of the user and you come back into the game, your game will not get a notification that the user signed out. It's your job to know that you come back from being constrained to actually check whether or not your user is still there, or if they change controllers. And that goes into controller management. Authoring issues. Your submission will fail if you accidentally include a debug library or use an expired SDK version. Thankfully, most of the tools will tell you about this issue before you actually submit, so you should be able to catch most of that before you actually wait a week for certification to get back to you. Save data is also a tough one. Several platforms have cloud support, cloud save support, so you have to make sure that you handle the cloud saves not syncing correctly, or the operation taking longer than expected, save data being corrupt, not being able to write save data because the file system is full. And that actually leads into the next one, error handling. So error handling is a really big one. Every system is very specific about how your game is supposed to notify the user about certain issues. One issue that we just failed for with Mille Noir was that on Switch, was that if you try to view the leaderboards, but there's a pending update to the game, you have to pass that error message on to the user. But there are a whole bunch of other error messages that you are not supposed to pass along to the user. I already talked about save data being corrupt and not being loaded. And then I also want to give a quick point on localization. It's a weird thing that we run into with Unity sometimes. Fun fact that the decimal separator is typically a decimal point here in North America, but it could be a comma or it could be a space in other countries or other locales. So when we serialize numbers to strings for our save data, Unity would use whatever the current decimal separator is, and they would write that number out into a string with it. But if you were to save your data with the game using one language and then try to load your save data using a different language, it would not be able to process it. You can tell Unity, you can force it to use the decimal separator for every locale. Also, you should check with the system language when your game starts up and update your game's localization to use that current language. Okay, so you failed for an issue. You can get a waiver for some issues. Every system has a process for requesting and granting waivers for a failure that you may not be able to solve, but generally these are not very easy to get, and they take time. So if you do need to request a waiver, it will help increase your odds if you do everything that you can to make sure that there is no suitable alternative. Diagnosing the issue with a standalone app, working with support to confirm that the issue is actually out of your hands. And the business team at the platform companies will talk about it for days before they get back to you and let you know that whether you get a yes or no. Sweet, so you've done everything. Your game's ready to go. Your ROM is finally approved. Now you actually get to do the publishing work. I find that the marketing assets required for the digital storefronts to be super complicated. It just might be that I also don't have a lot of fun with it. It can be very time consuming to compile a list of all the requirements for the assets that you need and generate them. I think having your key art in a Photoshop file with layers will help you out a lot. Being an artist would also help. You'll need to generate and submit a whole bunch of media files. You'll have screenshots 6 to 10, something like that, anywhere between either 720p or 1080p. Hero banners with your game art, some with your logo, some without. And your trailers might need to have very specific logo usage and legal text. If you're going to put the PlayStation logo on anything, they have very strict rules about how it looks, where you put it, and stuff like that. You may also need to localize your store copy text and then trim it to fit certain length requirements. I hate writing copy, so I think this is why I don't like publishing games anymore. So you have your ROM approval and your store asset approval. That means you can now actually schedule your game's release date. Each platform is going to require some amount of lead time ahead of your release, so you should anticipate at least 2 weeks after everything is ready to go before you can even put it on the store. And if you can, give yourself more time than that. If you're targeting multiple platforms or you're targeting a system where you have separate ROMs for each region, then you have to work with everybody separately to try to coordinate a release date. And getting everybody on the same date is pretty difficult. Also, every platform holder uses different dates when they update their store. I believe Nintendo's on Thursday, Microsoft is on Wednesday or Friday. PlayStation America might be Wednesday, and PlayStation Europe might be on Tuesday. I don't know what's best. You don't have to use the dates that they use, but that's the day that that platform sends out their information to the press. So it's up to you whether or not you follow their guidance or you just pick a day for everything, the same day for everything. So I think the part that PC developers, especially Steam developers, have the biggest issue with on consoles is updating their game. I think with Steam you can just update it and hit a button and you're good to go. And if you break it, it's your fault, and then you just do it again. Updating your game on consoles is done with patches, and those patches need to go through the same submission and certification process as your initial ROM. Sometimes the testing is expedited, but it's still tested, and you run the risk of it failing for new issues or old issues that were missed in your previous submission. And the process in which that you create the patch is also different on every system. In one system, you'll create your ROM like normal, submit it, and if it's approved, then the servers will generate the binary diff for players based on what cumulative patches they already have installed. Alternatively, you create a ROM like normal, but then you use a special tool that will then create a patch for you based on your previous submission. So I really hope you kept your previous submission. Or another platform, you actually create a patch ROM directly, where instead of bundling all of your assets together, you just bundle the assets that have changed. So that's it. That was the bird's eye view of everything. I actually didn't have Unreal. I'm sorry, that's there. So, yeah, I think we have time for questions. If there's anything, thank you.
Yeah, we actually have plenty of time for questions. There's a microphone up there. So, yeah, you can queue up behind whoever's there. We have, I think, about 15 minutes for questions. Let's give him one more round of applause. Thanks, Thomas.
Thank you for coming. It's Monday morning. It's amazing. Yeah.
Can you talk about your relationship with the developers you work with? Who submits? Do you have a kind of a publisher relationship sometimes? I'm really curious as to how that all works. Do you use the dev kits? Do you bring the developers in? How does that all fit together? That's
a great question. The way that we work is actually pretty flexible. We've actually done all kinds of things. As a third party to the guys who are actually their game. Fortunately, all the developer portals let you share access to a title with somebody else who is not in your company. So they can set up everything on the publisher end and then just share the back-end access with us, and then we can do all the work ourselves. We have the dev kits, we do all the work. Sometimes they'll have a dev kit and we can give them a build and they can evaluate it. And when possible, I like to take the game through submissions myself. That means if there are issues, I hear about them directly rather than going to the developer and then waiting to hear it back. But oftentimes, once the ROM is approved, all the actual publishing work is still taken care of by them.
I had a question about networking. So I'm just getting started on the Steam API networking stuff for Unity and trying to set up a really simple 2D multiplayer game using the peer-to-peer system, but I want to add like a layer in between that's an abstraction so that it's easier to get it on Switch or other things. Do you have any suggestions for basic architecture? Is it just a simple, packet array with a size thing that I'm sending out, or into a kind of an abstracted function, or any input there?
Yeah, basically for networking, if you're using sockets and you're not using a third-party plugin like Photon or something that has where it may or may not be supported on the platform. If you're doing it yourself, you'll probably have an easier time. You're familiar with the APIs. You can pick up how to implement anything else. Sockets are the same on every system, essentially.
Is the basic sort of framework for like getting friend invite callbacks or other things, like I don't know how familiar you are with the Steam API.
I'm not.
You're not? All right, well,
yeah.
Okay, I guess it's hard to answer that question then. Between PlayStation, Sony, and Switch, are those APIs similar for the networking?
Essentially, the way that you process callbacks or failure cases is going to be different. But everybody has a matchmaking system. Everybody has like a list of friends that you can get access to. Invites are a little bit different, but you are able to essentially, there's a presence system so that players can see that you're doing a thing, and they can use that to make it easier to connect.
Okay, thank you.
Hi, this is kind of connects back to a few different things you talked about.
Cool.
I was curious what your thoughts and opinions are on various open source libraries, code libraries for .NET were making use of things like SQLite, nlog, NoSQL, things like that. Have you run into any issues there? Have any opinions there?
Yeah. So like C++ projects, as an example, I'll get into C# in a second. So, but for C++, we've had projects that are using Lua. We've had projects using SDL or Boost. I don't know if SDL is open source or not, but like using those libraries that you have the source to is actually pretty easy. For C#, we've ran into some weird issues with like JSON Lite or something, where it's fine, it runs fine, but there's sometimes the Unity will strip out functions that it doesn't think that you're using, and for some reason that doesn't happen on PC versus when it does happen on console. But there are workarounds. You can, like, for the JSON example, we actually had you set up an XML file and you specify that you are using these system calls, even if it can't detect that, so that it makes sure that it includes them, doesn't get stripped out, and then your game should still run just fine.
Thanks.
Since you have the bullet point and all, any Unreal best processes that or best practices that are common issues?
Yeah, okay, that'd be great. Some really weird Unity issues, or Unreal issues that we run into are like your C++ code, your obviously C++ 11 code, not always compiling for another platform. The C++ 11 support isn't the same. PS4 and Switch both use Clang instead of Visual Studio as its compiler. So while the game can compile just fine on Xbox, and we try to compile on Switch, and we're getting all kinds of like errors we just hadn't seen before. We are constantly running into problems with the cooker that I just have not still wrapped my head around. Every time we update to a new version, well, that's just a problem. That's not advice. Sorry.
At least it's a shared problem.
Yeah, right. I'm sure. Does everybody run into this?
Yeah, pretty much.
That's good to know. Like iterating, for some reason, that doesn't actually iterate. I don't know what the point of that is. Yeah. Let's see. There are some plugins where it was meant for PC support or Xbox support, and we need to remove it for Switch or PS4. But we can't because there are blueprints in code that actually depend on those plugins being there. So you can't remove the plugins, you just have to find, and they're not meant to be disabled without just being removed. So we'd have to go in and actually like edit the plugin source so that it would basically be a no-op on a platform we don't want it to do anything. Updating Unreal versions is always surprisingly more difficult than I expect. Primarily, mostly the cooking issues, and blueprint nativization always sort of just failing. Yeah. Oh, something a friend told me, which I didn't even realize this, but it's should be super obvious. Whenever you, if you're using blueprint nativization to help with performance, that means if you were to make any changes to blueprints and you want to patch, you're patching your executable, not content, which is fine. It's just something to know about. You would have to do a patch rather than like serving a content change over the server, your Destiny or something like that.
Cool. Thanks so much. Appreciate it.
Yeah, you're welcome.
Hi. Could you go into more detail on how to convert the Unity project to work with asset bundles?
Yeah, I definitely can. So asset bundles on Unity are, man, I want them to just work better. So, and I'm still super confused about how they actually work. So what we do essentially for the consoles, we'll go through and we'll put all of the scenes, just the scene files, into an asset bundle. We'll either put them all into one asset bundle, or we'll put them into groups of asset bundles based on like groups of levels that we can load and unload the asset bundles. You'll need an editor script that will build asset bundles. It's an API call that Unity has. You just need to make an editor script that will call that function, or that will build all of the bundles that you want to build. Then in game, your actual game script, you just have to manage loading or unloading bundles as needed, but loading a scene is still the same API call. So once the bundle is loaded, Unity automatically handles loading that scene from a bundle versus just loading it from however Unity loads in scenes. There's another area, your resources files. Unity has a very different way of handling file I/O for anything that's in the resources folder. Excuse me. So those file read-write, accessing the file system for the resources folder could possibly be a cert failure based on how frequent you were to do it. So I also recommend putting anything in your resources folder into an asset bundle, loading that bundle and just keeping it loaded. That one will require much different API changes throughout your code. I would recommend a centralized like resource manager that instead of calling resources.load, you call your resource manager.load, and it will either load it from an asset bundle or load it from resources. If you have more questions about that, just come back up.
How much effort is involved in developing for the docking, undocking, and then the PS4, PS4 Pro, sort of optimizing for the different states of the hardware?
Man, specifically for Unity or just in general?
Just in general.
It's surprisingly easy. The Nintendo, whether it's docked or undocked, you can, the Switch, when it's docked, you have slightly improved GPU speed. It doesn't actually help with performance all that much, but it does give you a little bit more bandwidth in order to get up to 1080p rather than 720p when you're docked. And that's a very easy flag to check or set. You can also disable it, so it doesn't actually change anything when you go from docked to undocked. PS4 Pro and Xbox One X, basically just 4K support and HDMI. There are some rendering change, like your actual rendering APIs might be different. Your back buffer is obviously going to be different. Unity handles that really easy. Unreal handles that really easily. If you're doing that in C++, it's probably a bit more work.
Hi. Much of what was discussed was kind of focused on how to port an existing game over. Yeah. And I was wondering if you could comment on maybe how, if you were working on an unfinished game, how that would affect the whole timeline of submission, cert, and I guess maybe like what point in the project would you consider starting to go through that whole process, even if you don't really quite have the final 3 months of the finished game?
That's a pretty good question. So like when should you start basically porting if your game you're still in the middle of developing your game?
Yeah, basically. It wouldn't really be considered maybe a port, but
right. Adding platform support
right.
to your game. I would still call it porting, but yeah, because often we're working with developers who are still working on their game. Sometimes we get a game that's completely done and then we're just doing the port sending it off. But then sometimes we're actually adding Switch support or Xbox support while the game is still in development. That does help your timeline because you get all the pre-publishing work done while you're in development. You're able to get the game running on the system while you're in development, which means you can find all the performance issues that you're going to run into while you're still making content. So you find out that your draw calls are too huge, or you got way too much stuff on the screen. You don't have visibility culling set up. It's much easier to tackle those problems while you're still making the content versus like coming in after the fact. Then you get to set benchmarks for yourself essentially. The submissions work it doesn't overlap very well with development though. You'll submit the game and you'll fail. You could still be working on the game while it fails, or while you're waiting for it to fail your first time, but it's not a super great use of time.
Yeah, are there any kind of rules you have to keep in mind if you're sort of submit something for cert, but is that kind of everything after that kind of just gets interpreted as like a day one patch or?
If you were to submit your game and then you wanted to continue working on it while you're waiting for your submission, I recommend please use source control. If you're using source control, you have a branch of what your submission is. You should branch on every submission. And then you can continue working on your game. And if it passes, and then you have a marker that's very easy for you to like make another build if you needed to of that, and pull in other changes that you've continued to make. Or you have all of the changes that you've made since then, you could use as then making a day one patch if you give yourself enough time for another submission, for that submission to pass, and schedule the release date for.
All right, thank you.
You're welcome.
Hey.
Hi.
Have you ever had a project that you couldn't port to console, like the code was too spaghetti code or anything, and if so, what went wrong?
Not yet. I'm a little nervous about that, but I have a hard time saying no to stuff. I like the games that we've been getting so far. We had some very difficult code bases that we have worked in, but we've always kind of found a way to make it work. There was one game, Punch Club for 3DS. We actually ported the game out of Unity and into C++, and we drastically underestimated the amount of work that would take.
Why did you do that? Why did you have to?
Oh yeah, it's like, why would you make such a terrible decision? That's a great question. There is Unity support on the 3DS, but it primarily is targeted for the new 3DS. It has a faster processor and more RAM. We wanted to get the game out on the regular 3DS in order to have more units of the game bought. Also, we just really wanted the challenge. It was really neat. It was a really interesting way to learn about Unity, is trying to recreate Unity runtime in a different engine. Yeah. But yeah.
Yeah, I guess the source of my question is sort of wondering what types of code problems, architectures people make, like what mistakes.
Oh man. Okay, so there is one game where we were actually fixing a port for a game that was already ported, and the console implementation is all in one file. There's no encapsulation, there's no separation of systems at all. It's like a 35,000 line file that has everything in it, and it is unwieldy to navigate and not ideal. Yeah. Yeah, separation, encapsulation, abstraction, all your friends. Be good programmers.